So how to convert hexadecimal notation to binary and vice versa. So how do we convert this 2-digit hex number into decimal? I'll leave out names. Go for it.
Okay.
What should I do?
So, that's good. I'm trying to remember
This
this.
is great. Yeah.
Well, each thing has so there's 9 numbers. There's 10. There's 1, 2, 3, 4, 5, 6, 7,
Yeah.
8, and 9. And
Okay.
then after that, there's A, B, C, D, E, and F.
Okay, so we've got 0 to 9, and then A to F, which gives us, that should be an F, yeah.
Yeah, and then goes up to all of 16.
Which gives us 16 numbers,
Yeah.
which is where hexadecimal comes from, yeah?
And
So,
then, after 9, then A is 10.
yep.
B is 12. C is 13, and C 13.
So F would be what value?
15.
D and F is 15. Okay, so looking at that, we've got the value of 15, and D then we can work
13.
out is 13. So then we take each of them as a 4
Binary.
Yeah, 4-digit binary, which is known as a nibble. Yes, we take each as a nibble. So 15 is a nibble if we take 1, 2, 4, and 8. 1, 2, 4, and 8. So 15 would be
All of them.
all of them. So 1, 1, 1, 1. And 13?
1, 1, 0, 1.
1, 1, 0, 1. Which would give us an 8-bit number that represents D and F. And then converting that into our denary number, what would the equivalent be for that? Yes?
So, for the first value, for the first 4 bits, binary of the whole 8-bit number,
Yep.
you look at the value. First, you take the value, which is 13.
Okay, so 13.
So you multiply it by 16 because it will be 16 bits. That's the maximum number for the hex.
To the power of 1, yeah?
To the power of 1, yes, which is 13 times 16.
Uh-huh.
And then you add the next half of the binary value.
Yeah, so it'll be 15.
15 times 16 to the power of 1.
16 to the power of 0.
Which is just 15. So 15 plus 208 is
Okay.
220.
So 208 plus 15
Yeah, 223.
is going to give us
223.
223. Okay, so if we think back to the previous numbers, we would have 1, 2, 4, 8, 16. This would normally be 32, wouldn't it?
Yes.
So we can just check it quickly by doing 255 minus 32, can't we? Which would give us 3, 2, 2. So this part works here, yeah? Now the next one we're expected to do is convert this to hex and into a decimal value. So how would we go about doing that? What do we do first? Both. So let's do hex first. The first one is 14, yep. This side's 14. And this side? 12. Awesome. Yep. Then what? How do we get the hex value then? Which one is? 12 is C. And 14 is E. So our hex equivalent for that is CE. Agreed?
Yes.
Yeah, happy? Okay, how do we work out then, using the hex multiplication we've been learning about, what value that is, rather than add them all up by doing 1, 2, 4, 8, 16, 32, 64, 128. So there must be an easy way to do it. So what is it? Yeah.
And would it be like brackets 12 times 16 to the power of 1?
12 times 60 to the power of 1, indeed, yeah.
And then you plus
Yes.
14 times 16 to the power of 0.
16 to the power of 0, good, because it's 16, it's base 16. The same principles for binary apply, which would be, that one's easy. 14, what's 12?
192.
It's 192. Plus 14.
216. What a bench.
So what do we think?
206.
206.
Yeah.
And if we go back and add this up the slow, long way, hopefully we'd realise that we end up with the same number. And the only other way we can get asked this is by being asked what is this number as hex and as binary. So what do we do to this number then?
This number is special because it's 2 to the power 16, which is how many different characters.
This is 2 to the power 16, is it?
It's one less.
It's 1 less.
One less
Yes,
than-
okay, which was intentional. So what do we do to this number then?
You divide it by 16.
So we divide it by 16, so help me out, I don't have a calculator, can someone tell me what we get?
You
It's
would get
4,095 with a remainder
Four.
of 1.
1,095, remainder?
15.
Remainder 15, okay, so the remainders are important here. And then we repeat the process for this piece,
255.
355,
250.
200, sorry, and the remainder,
15 again.
15 again. And we do the same process again, which leaves us with
15, and it's remainder 15.
15, remainder 15. Now the minute that you do this, technically this one is 0, remainder 15. That will let us have worked out what the hex value is, because hopefully you can remember that f is 15. And we read it in reverse order, so it doesn't really matter for this one anyway. You would end up with f, 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 f. And by applying what we learned a minute ago, we should know that if we do 15 times 16 to the power 3 plus all the way, we would return back to this number here. But it also asks us how to get the binary value, and hopefully we know that it's 1111, 1111, 1111, 1111, yeah, by converting all the f's. Awesome.